Welcome to presentation on OWASP Top 10 Web Application Security Risk, which was published in 2017. My name is Zishan Kazpersa. First, introduction and why you should care. OWASP stands for Open Web Application Security Project, which is a non-profit organization that provides information about application security. Every few years, OWASP produces a list of top 10 web application security risks to help security professionals out be aware of more common found vulnerabilities in web application. This list called OWASP Top 10 was last updated in 2017. The list mostly focuses on serious web application security risks, and for each risk it uses a table which says likelihood times impact equals a risk rating. This risk rating should allow an organization to understand the risk if an item from the list is found and how to prioritize fix for it. According to a report published by Verizon called 28 Data Breach Investigation Report, the most prevalent breach pattern was web applications. This highlights how important it is to let the list of top 10 web application risks be at least the starting point for our web application to protect against. The list basically describes the vulnerabilities, tells you the risk ranking for it, gives you some examples how to identify it, and then a few examples on how to protect against it. Three main ideas we will be covering in this presentation would be the list by itself, its description, and the risk rankings associated to it. Second would be how to identify vulnerabilities from a OWASP list if it's present in your application. Third, how to prevent it in your application. Here's the top 10. Here's the list of top 10. Injection, broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfiguration, cross-site scripting, insecurity deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. Now we'll go into details of each. First is injection. Injection flaws such as SQL, NoSQL, OS, LDAP injection occurs when untrusted data is sent to an interpreter as part of a command or query. The attacker hostile data can trick the interpreter into executing unintended commands or accessing data without proper authorization. How can you tell if your application has this? User supplied data is not validated. Dynamic queries or non-parameters called without context of escape are used directly in the interpreter. Hostile data is used with an object relational mapping. Hostile data is directly used or concatenated. How can you prevent it? Preferred option is to use safe APIs, which avoid the use of interpreter entirely or provide a parameterized interface, or migrate to use object relational mapping tools. Use positive or whitelist server-side input validation. Use escape special. Use for any residual dynamic query escape special character using specific escape syntax for the interpreter. Use limit and other SQL controls within query to prevent mass disclosure, reckon and scale in case of SQL injection. Next is broken. Well, here are some of the scenarios: untrusted data in creating SQL, cool, blind trust in frameworks such as HQL, and then attacker is able to modify the ID parameter and retrieve the complete list. Next is broken authentication. Application functions related to authentication and session management are often implemented incorrectly, allowing attackers to compromise password keys or session tokens to exploit other implementation flaws to assume other users' identity temporarily or permanently. How can you tell your application has this problem? Permits automated attacks such as credential stuffing, permits brute force or other automated attacks, permit default weak or well-known passwords such as password1 or admin, user weak or ineffective credential recovery, uses plain text encryption or weakly hashed password, has missing or ineffective multi-factor authentication, exposure session IDs, does not rotate session IDs, does not properly invalidate session IDs. How can you prevent it? For possible multi-factor authentication, do not ship or deploy with any default credentials, particularly for admin users. Implement weak password check, align password length, complexity and rotations policies with NIST 800-63B, ensure registration, credential recovery, and API pathways or hardened against account enumeration attack, use server-side secure built-in session management that generates a new random session ID. So this potential, again, some of the scenarios, again, credential stuffing, password as a sole factor, session timeout, or not set up properly. Next is sensitive data exposure. Many web applications and do not properly protect sensitive data such as financial health and PI data. Attackers may steal or modify such weakly protected data to conduct credit card frauds, attempted theft, or other crimes. Sensitive data being compromised without actual protection, such as encryption or rest. Encryption at rest or in transit, and require special precautions when exchanged with the browser. How can you tell if your application has these monitoring? Is any data transmitted in clear text? Are any old weak cryptographic algorithms used? Are default crypto keys in use? Is encryption not enforced? Does the user agent not verify the received server certificate is valid? How can you prevent it? Classify data. Apply control as per the classification on it. Don't store sensitive data unnecessarily. Make sure to encrypt all sensitive data. Ensure up-to-date and strong standard algorithm, protocol, and keys are in place. Encrypt all data in transit and secure product protocols such as TLS. Disable caching for response that contains sensitive data. Store password using store and adapted salted hashing functions with a work factor. Verify independently the effectiveness of configurations and settings. Again, scenario encrypt data is automatically decrypting when retrieving. Site doesn't enforce TLS. Password data was using salted or simple hashing. Next on the list is XML external entities. Many older or poorly configured processes evaluate XML processes evaluate external entity reference with an XML document. XML can be used to disclose internal files using the file handler. Internal file share, internal port scanning, remote code execution, and denial of service attack. Can you tell the application has it? The application accepts XML directly. Any of the XML processes in the application is sub-based web server has a documented definition. Application uses SAML for identity processing within federated security or single sign-on purpose. If the application used for prior version of workload is likely susceptible to XSC attack, and XML being vulnerable to XSC attack likely means the application is vulnerable to denial of service attack. How can you prevent it when a policy uses less complex data formats such as JSON, patch or upgrade all XML processing libraries, disable XML external entity and DTD processing in all XML, implement positive whitelisting, server-side input validation, verify that XML or XSL file upload function validates incoming XML. So the scenario, attacker attempts to extract data from the server, attacker probes the server private network, server attacker attempts to deny service attack. Next one on the list is broken access control. Restriction on what unauthenticated users are allowed to do are often not properly enforced. These flaws to accesses unauthorized functionality or data, such access other users' account, use sensitive files, modify other users' data, change access rights, and etc. How can you tell the application has this? By passing as control checks by modifying the URL, allowing the primary key to be changed to another user records, elevating or elevation of privileges, metadata manipulation such as playing or tampering with JSON web tokens, coarse misconfiguration, allowing unauthorized API access, force browsing to authenticate page as an unauthenticated user or to privilege pages as standard user. How can you prevent this? With the exception of public resources denied by default, implement access control mechanism to reuse them throughout the application, including minimizing coarse usage. Model access control should enforce record ownership rather than accepting the user can create, read, edit, or delete any records. Unique application business limit requirements should be enforced by domain model. Disable web service directory listing, log access control failures. Rate limit API control access to minimize the harm from automatic attack tooling. And here's a scenario: app uses unverified data in SQL call. Attacker modifies pattern profile in the browser. And scenario 2, attacker forces target URL. Next is security misconfiguration. Misconfiguration is the most commonly seen issue. This commonly results of insecure default configuration, incomplete or ad hoc configuration, open cloud storage misconfiguration, STP header, verbose error messages containing sensitive information. Almost all operating system frameworks, libraries, and applications be security configured, but they must be patched and graded in a timely manner. Can you tell you have these issues? Missing appropriate security, hardening across any part of the application stack or configuration permission on cloud services. Unnecessary features are enabled, default accounts and their passwords still enabled and changed. Error reveal stack trace for upgrade system, latest security features are disabled. Software out of date or vulnerable. How to prevent it? Repeatable hardening process that makes it fast and easy to deploy in another environment. The minimal platform without unnecessary features, component and documentation and samples. Task to review and update the configuration appropriate to all security roles. Updated patching as part of the patch management process. Sending security directives to clients. Automated process to verify effectiveness of the configuration and setting in all environments. And here are some of the examples. Sample application are never removed, directly listing not disabled, server configuration live for detailed automation. Cloud provider has default sharing permissions on. For item number 7, XSS flaws or cross-site scripting. XSS flaws when our application includes untrusted data in a new web page without proper validation or escaping or updating an existing web page with the user supplied data using a browser API that can create HTML JavaScript. XSS allows attackers to execute script in the victim's browser, which can hijack user session, deface website, or redirect the user to malicious site. How can you tell your application has it? Reflected access application API includes unvalidated and unnecessary escape and user input as part of HTML output. Application or API stores unnecessary user input that is viewed at a later time by another user or administrator. Just confirm a single page application API that dynamically include attack control. Data to page are vulnerable to DOM access. Can you prevent it? Using frameworks that automatically escape access by design, escaping untrusted HTTP request data based on context and HTML, applying context-sensitive encoding. Here are some of the examples. The application using untrusted data and creating HTML snippet. Attacker then modifies the name parameter, hijacks current session. Item number 8 on the list is insecure deserialization. Secure detention often leads to remote code execution, even if the detection of flaws do not result in remote code execution used to perform it. Include name replay attack, injection attack, and privilege escape attack. How can you tell if your application is vulnerable? Object data structure related attacks where the attack modifies application logic or achieves arbitrary remote code execution. If there are classes available to application that can change behavior during or after utilization. Typical data tampering attacks such as access control related attacks where existing data structure are used but the content is changed. Can you prevent it? Implementing integrity checks, enforcing strict type of constraint during deserialization, assigning anyone that deserializes in a low privilege environment, log deserialization, execution, and failures, restricting or monitoring incoming and outgoing connectivity from constraints or server that deserialize. Here's an example. Application uses serialization to store cookies with user ID, role, password, hash, and other state. Attacker changes the object to get admin privileges. Next is using components for known vulnerability, compulsive libraries, framework, other framework modules run with the same privilege as the application. If the vulnerable component is exploited, such as attacking facilitate serious data loss or server takeover. Application are using components with known vulnerability may undermine application defense and enable various attacks and impacts. How can you tell if your application while using it if you do not know the version of all components? If software is vulnerable and supported or out of date, if you do not understand for vulnerabilities, if you do not fix or upgrade the underlying platform, framework and dependencies in a risk-based, timely fashion. If software developers do not test compatibility of update, upgrade, or patch, if you do not secure components configuration. How can you prevent it? Remove unused dependencies. Continuously inventory the version of both client-side and server-side components. Only upload components will officially source or secure link. Monitor for libraries and components. Scenario components run at the same privilege as the application itself. Any flaws can impact the application. The last one on the list is insufficient logging and monitoring. Insufficient logging and monitoring coupled with missing or ineffective integration with incident response allows attackers to further attack system, maintain personnel, pivot for more system, and tamper, extract, and destroy data. Most researchers show data time to detect the breach is over 200 days. Typically detected by external parties rather than internal processing or monitoring. Can you tell if your application is vulnerable to this? Auditable events such as login failure, logins, and high value transactions are not logged. Warning there are generated no inadequate or unclear log message. Warnings and errors generate no inadequate or unclear log messages. Log of application if they are not monitored. Logs are only stored locally. Appropriate alerting threshold and response discrimination process are not placed or effective. Penetration testing and scan tools do not trigger alerts. The application is able to detect, escalate, or alert active attack in real time, or the application is unable to detect, escalate, or alert for active attacks in real time or near real time. Can you prevent it? Ensure all login, access control failure, and server-side input validation failures can be logged. Ensure that logs are generated in a format that can be easily consumed by centralized log management solution. Ensure how vulnerability transactions have an audit trail. Establish a free monitoring alert such that suspicious activities are detected and responded. Establish or adapt an incident response and recovery plan. Scenario opportunities firm hacked. An open source project form software run by a small team was hacked using flaws in its software. The attacker managed to wipe out the internal source core repository containing the next version and all the form content. All the source could be recovered. The lack of monitoring, logging, or alerting led to a far worse breach. The forum software was no longer active as a result of this issue. Attacker uses scans for users using common passwords. And the other last one is unanswered threats. So basically, in conclusion, the biggest reason for OWASP Top 10 is to educate different people involved in development or maintenance of web applications in an organization for most common and important web application security weaknesses. It provides techniques on how to identify vulnerabilities and how to possibly resolve for them. This can be a great starting point for organizations to start from and then build upon it. Critical Nest, visit the actual OWASP Top 10 list. There's the OWASP Top 10 cheat sheet that tells you issues and how to solve for them, OWASP risk ranking, and what's next for developers. Thank you so much.